Awesome. Hey, guys. So my name's Yon. Some of you have heard from me before. This large, raucous crowd down here at the bottom is a couple of my teammates. So if I don't know the answer to any questions, I'm probably going to make them answer it. And I'm going to talk to you today about Docker and how we use it at SalesforceIQ, not RelateIQ as of 5 a.m. So if you see RelateIQ, you should yell at me. So before we begin, I just wanted to give you a quick background of who I am, what I'm doing here, and why I'm telling you about Docker. So RelateIQ has been using Docker for about 2 years, give or take. And we've been using it since the beginning, since the 0.6 era. And we've gotten to grow and benefit from using Docker, and we've actually done a lot of really cool stuff with Docker that was very quickly replaced by better open source implementations, as they should be. And we do a lot of cool shit with it. So, so I'll tell you what we do. So so that's me. So who the hell are you guys? So who here knows what Docker is? Awesome, cool. There goes half my talk. Who here's deployed Docker for fun? Good. So about a little less than half. How about for development, local development? And this whole front row should be raising their hands. Production? And how about at scale? Do you guys run hundreds or thousands of containers? Front row, you should still be raising your hands. You're killing me, guys. You're killing me. And finally, I'm just going to throw this in there because I see his name all the time and I follow him on Twitter. But who here's heard of Jerome Pettazzoni? Excellent. He's going to show up in a few minutes. So what is Docker? So there are a lot of answers to this question. The one that I like to start with is a wall of text. So I work in the development side and in the operations side. And so I see a lot of things like this, where a developer comes up with this crazy bug that he found in the garbage collector for Java version 1.8.037-C22. So we can't launch that in production because of messes with our whole system. But we can't launch it right away. We can't launch the updated version right away because it's only in staging. So the ops team can't do anything about it, and they basically have to follow the code deployment. So if you have a production environment, you have a staging environment, maybe you're cool enough to have a canary environment, all of a sudden your operations team needs to make sure that all of the machines are properly re-provisioned and properly updated for the code release. And that's weird. I mean, that's kind of fun. You get to be a part of the release process. But let's be honest, upgrading Java on a machine is awesome. Much less on hundreds of machines, right? So we've done that a few times, and then we very quickly switched over to Docker, which I promise solves that. Similarly, for other reasons, if you wanted to do something that was really hard, but deceptively so, if you were on a CentOS machine, CentOS uses Python 2.4.3, I think, to manage its package management system, Yum. So you can't actually upgrade the system version of Python on those machines. You have to use virtualenv, or you have to do some other localized install of Python in order to get Python running on a machine. And that's basically not fair to an ops team, and it's not fair to a developer team, because all of a sudden you're asking the ops team to know about this weird, nuanced thing because we're using this package manager and we're doing that and the blah, 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 blah. And then every developer who's trying to use your CentOS-based deployment system is getting pissed because you can't run Python 3.3.3, and you can't use hash rockets to do maps, and you can't do this, and you can't do that. It's just not fair. Or at least that's how I feel. So that's why I'm super passionate about Docker, because it fixes that. And I'll show you how it fixes it in a little bit. And then on a more serious note, so Docker, I have a whole bunch of bullets for what I think of when I think of Docker, and it's an evolution of LXC containers. So the Linux kernel developers came up with this really clever idea of, oh my God, what if we isolate the CPU? What if we isolate file systems? What if we isolate networks? What if we isolate memory blocks? And they designed this really cool framework for isolation of stuff, and it turns out it was really hard to use. And so these guys from Docker wrapped that in a file and wrapped it in a nice, clean interface and made that available to the rest of the world. It's also, so it's file system isolation, but more importantly and more interestingly, it's also a layered immutable file system and a bunch of tooling around this idea. And I'll show you what that looks like in a few moments. It's also an ecosystem of tools around containers to make containers easy to deploy, easy to build, easy to update, easy to debug, and easy to link together. And then I have some hand-wavy things that it's how you make dev and ops happy with each other. It's something that my devs work on, and it's something my ops team runs. It's also something my devs can run, and it's something that my ops team builds with some regularity. We ship, I think, 1,000 containers right now, 1,000 unique containers to do everything from like our S3 backups to our deployment to our internal tools system, a few other things like that. And the reason, I like to think that the reason that this has become such a huge trend is because it's a really easy language for communication. So instead of talking like packages or code or virtual env or rbenv or pip or easy install, it's a one thing that no matter what it is that you want to run, ops team understands how to run Docker, and dev team, it's really easy to onboard and get them running and writing Docker. So I like to think of that as the culture or the language that facilitates a good, healthy culture. So what do you guys ship? Do you ship code? Sorry, this is super interactive, so you guys should feel free to yell at me at any time. I am not a professional speaker. I just answer questions because I like tech stuff. So what do you guys actually ship? You ship jar files. Well, so you ship binaries. So who runs those binaries? How do you make sure that the Java version isn't incompatible, or the Jetty, if you're shipping a WAR, how do you make sure that the Jetty guy isn't running either the wrong garbage collector, the wrong GC logging levels, the wrong, Java. There are people whose jobs it is to make sure that your JVMs are awesome. And that's cool. I don't want to do those. You can ship anything, right? So you can ship code, which runs into this issue where if you have to worry about your interpreter that you're shipping the code to, like if you deploy, for example, a Python or Rails app, you might be shipping, or not Rails. I don't remember. Rails compiles, right? No, it doesn't. Oh, it interprets. OK, cool. So you ship like a Ruby interpreter, you ship a Python interpreter, or you hope that the Python interpreter on the machine that you're deploying to in production is the same version that you're deploying to on your laptop, which maybe you forgot to update Brew, or maybe Brew is bleeding edge, and you're relying on a feature that doesn't actually exist. You might ship binaries, in which case you have to worry about whether you're like dynamically linking to anything that's actually on the system. So even if you're compiling like C or C++, if you're running a version of libSSL that has like a security vulnerability, that's like, or it depends on a library that's not backwards compatible, that's the fun that the ops team gets to get. That's the joke between like works online, works locally. You might ship a package. So if you have a really mature team, you might ship like a yum or an apt-get, or I think Yahoo has its own package management system. So you can ship all sorts of things, and all of them come with their like weird, annoying nuances, whether you're running the wrong version of Linux or you have the wrong interpreters installed. And that's no fun for anyone. So Docker is cool because you ship a container, and that's all you ship. So you always ship a container, and that container is a thing that knows how to run itself. Cool. So if you ship containers, let's talk. So a lot of people ask me what Docker is. Like, how do you ship a Docker? Do I deploy my Docker file? Totally legit question, because I asked the same thing when I started learning. I like to break it down in two ways. There are two fundamental things that matter about Docker. There's a whole bunch of other stuff like network stack and volumes and blah, blah, blah. But the two things that actually matter are an image and a container. And the difference between them is that an image is a thing that you build and give to your ops team to run. So it's a deploy target. It's a thing that you can build. It's a thing that you can version. It's a thing that you can pull, any sort of an artifact. And it's comprised of a bunch of immutable layers. And I actually have a demo, so I'll actually show you some of those immutable layers in a few minutes. And it's comprised of a list of immutable layers. So you're shipping, now you're talking immutable infrastructure, sort of. And you apply that to whatever is in your base package. So for example, you might ship a container that starts off as Ubuntu, but then installs PHP and fast CGI and Nginx. And now you have a container that runs PHP really fast. That's great. I don't care. It answers on port 80, so that's all I have to worry about. The other thing that's important is a container. So a container is a running executable in an isolated file system built from these immutable layers. So you basically take an image and you photocopy it and put it into run space and start running stuff. So you have an immutable layer of infrastructure and then one mutable layer on top of that. So you can make changes to the file system. So if, for example, you have a bootstrap script that first thing it does is go and fetch a config file from some config server. It'll store it in that mutable layer. And then it might be network isolated, it might be memory isolated, it might be CPU isolated. That's cool, that's great. If you have to deal with like malicious users, it's a thing that's really important. My developers aren't like that, so I don't have to worry about that nearly as much, at least. So a Docker file, this is just a super simple example of a Docker file with an image that I threw together in 5 minutes. So it starts with a base layer called Node. And as you may have guessed, it comes with Node.js installed on it. It pulls in some data. It pulls in some files from my local file system, adds them as an immutable layer called opt/app. It might run npm install and install some of those Node packages, Node modules that are that this application depends on. And then at the end, you tell the container what it should run in lieu of, like if you start the container, what actually gets run. And in this case, it's npm start. So let's see if this works. Oh my God. All right, this is the fun part of the demo. If you can't read the text or don't like text-based demos, now's the time to leave, because this is where the rest of the presentation lives. So, sorry. Not sorry. So I have a Docker system running right now. Let's see if we can get, oh, that's so ugly. Is that still readable? Kind of? OK. So I have a few things running right now. So demo number 1. Oh, yeah, that's right. So one of the cool things that you can do with Docker is you can actually look at the layers. So I mentioned earlier that it's a layers of immutable file system diffs. And so you can actually look at those diffs. And so there's a command called Docker history, where you can basically ask for the history of a layer. And you can see, so it goes from the bottom up. It starts with some import. So some guy started with a base layer that isn't depictable as a thing. Adds 128 megabytes worth of files. Sets the default command for this container to be bash. Modifies a group. Does apt get update and install. Sets a few environment variables. Curls a few dependencies. Exposes a port. And then sets a user and a default command again. So you'll see that we have 2 default commands. Because this guy comes second, he wins. So, oh, yeah. Oh, that's the wrong folder. Desktop. Oh, cool. Please don't judge me. Demo Docker image. Cool. So I have a really simple Docker image here. And we can go back to being really big again. So I have a really simple Docker container here. Ooh, that is not interesting. And you can see all it does is start with a really thin version of Linux, adds an interesting file, and then sets the default command to be sh. So if we build it, SalesforceIQ. Cool. And it turns out I've already built it once before. So if we now run it, you can see that now we're in a different machine. And sort of like a virtual machine, except without a host operating system. So a lot of the expense from a virtual machine comes from interpreting from the guest OS to the host OS, doing that optimization of like Linux of the kernel. So we don't do any of that right now. So there's a weird thing with Docker where you can run Docker on anything as long as it's Ubuntu, or so the joke goes. So as long as your kernel has the right support for a container, you can actually run it. And it turns out, as soon as people realize that that's all it took, well, you'll see at the end, but it's become really popular in the community. So in this Docker container, you saw I added this interesting file. And that's cool. Go Dreamforce. And I'll just switch over to another tab. Yeah, I know. Docker PS, so you know. So you can see I'm running the Salesforce Dreamforce container right here. And it's been running for about a minute, and his name is 25DE299A0001. Super memorable. So his name is also Insane Sinasai. I have some fun default names here. So the cool thing about Docker is it's, as I mentioned, isolated. So if we run this guy again, if I create another Docker container, you'll see I also have an interesting file. Hooray, it worked. So I'm just going to set hostname to be 2. All right, whatever. So we don't overwrite. So I mentioned that there was an immutable layer, file system layer on top. So if we were, for example, to blow out this interesting file, you'll see there's nothing there anymore. But in this other container, obviously, I mean, whoop-de-hoo, right? Container isolation is amazing. So I can mess with this file and this environment without messing with everything else that's running on the machine. And that's really all I had to say about that. So, yay, Docker. Any questions? Now's the time to yell at me. No, nothing. All right, cool. Oh, yeah, I did have one more slide. So when you're doing local development for Docker, I mentioned earlier that it can run on anything as long as it's Ubuntu. So when we started with Docker 2 years ago, we actually wrote this thing called devenv. Because we said, well, as long as it's a Ubuntu, we can run it, right? So all we did was download a VirtualBox, and now we're running on a guest host, a Docker container in the guest host, so almost defeating the point, but it's OK. It's local development. It's not production. It doesn't matter. So we wrote a shell script that basically bootstrapped our whole development environment, and we got a whole bunch of good blog posts out of that. So engineering.salesforceiq.com, yes. You should totally go there. And then shortly thereafter, somebody realized, oh my God, that's like super pain in the ass to write a whole bunch of shell scripts to manage your container to describe something that's really repeatable. And so DRY applies, and they wrapped it in a YAML file and got a lot of good press and a lot of good development out of there. That's fig.sh before they were acquired. And then they also, at the same time, they realized that actually managing this virtual environment is a totally different problem, so it should maybe be a different thing. So Fig went one way and assumes that you have a Docker client somewhere, and then boot to Docker is another component which boots this virtual environment and manages it on your local environment, and deals with all the VM-specific stuff like SSHing in and getting the IP and blah, blah, blah. Yay, separation of concerns. And nowadays, they've actually evolved both of those tools pretty significantly. So now Fig was acquired by Docker, and they changed that tool to Docker Compose, and it's become a lot more powerful. It feels a little bit like if you wanted to start, if you've used Amazon, it feels a little bit like CloudFormation, where you can just be like, I want 3 of this, 2 of this, and 5 of this, go. And as long as you're talking to a Docker server, those containers spin up somewhere, linked together in the right way using network-defined networking, and work. At the same time, Docker Machine is the next step of boot to Docker. And Docker Machine lets you provision a VirtualBox environment on your local laptop, same as usual. But it also lets you build a Droplet or a Heroku build pack or an Amazon EC2 instance. And so the cool thing about this is now if you have a really complicated environment, Salesforce, and you wanted to run, for example, a giant Postgres server and a giant Memcached server and a giant Redis server too, because what the hell, memory is cheap, you could spin up a bunch of machines and deploy your local development environment to these remote machines. And it works, and it's really cool. So it's really easy for a developer to spin up a local development environment, and that's awesome. So it's actually so awesome that I had a tab open. Oh, yeah. What is a virtual machine? Let's see who. Where is it? No. All right. Probably should have prepared this. Oh, yeah. So if you have a bunch of Raspberry Pis, you can actually deploy Docker to a cluster of Raspberry Pis. You can see right here. And I actually did this, and it's actually really fun. Some complications because it runs ARM instead of x86, but whatever. So, should close that one. So why don't we go back to the command line again. So I'm going to go ahead and kill these two VMs. Docker ps, ps-a. So you saw I just exited one of those containers, and it's somewhere around here still. So you can see that we still have this container around. So for example, you can stop the running process. It saves everything to that mutable file system layer that sits on top. And then you can start it back up if you wanted to, for example, debug it or find out what was going on. Or if, for example, you accidentally broke production, you could, for example, decommission the new hot units that you thought you just deployed and then start up the old one with almost zero downtime. I've gotten a lot of mileage out of that one, more so than my peers, or so I'm told. Oh, yeah, and if you wanted to start a Docker container, machine create. Cool, I still have it. So I have this like ugly command line parameter here. If I wanted to spin up a machine in the EC2, it's a little bit more complicated because if you want it in a VPC, if you want it in a certain subgroup, if you want it with a certain region, if you want a certain blah, Amazon is configuration heavy, but you could run it. Oh, I already have one. Cool. So that's how you run. I mean, this is the state of the world with Docker. Ooh. Let's see, there. We'll just pretend that other stuff wasn't there. So you can see now with Docker machine, the next step of boot to Docker, I can actually manage, let's pretend I had production in there somewhere. I could manage my production environment from here if I so chose. If you're managing hundreds of machines, maybe a good idea, maybe not. So I have a few containers running. So I started these beforehand because I wasn't sure I would have network, and I don't think I do. So I have a couple of containers running locally, and I just wanted to show you really quickly the local development environment in action. We'll do Maven test. So I was working on a service. I was working on a very cool crypto service, which I'll probably open source at some point. And with this like push towards service-oriented architecture and blah, 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 microservices and et cetera, one of the things that comes up often is I would like to start one, and then I probably want to run like end-to-end tests on it. And so one of the things that we did for crypto, you can see 6 seconds, because hell yeah. One of the things that we wanted to do is actually spin up a database, spin up a Memcache server locally, and actually make sure that the thing works. And it turns out that's actually like kind of important, so I'm told. So not only do we have unit tests in this system, but if you scroll up here a little bit, you can see we're actually serving real queries in our tests. We have an access log right here. We're actually accessing our scoped tests, our scoped keys, our health checks, our auth endpoints, our credentials are somewhere in here. And so we actually have end-to-end unit testing on a microservice, and it doesn't really matter what it is. It happens to be written in Maven right here, but like I could have just as easily stuck it in a container and run Java. Oh, no. No, history, don't fail me. There it is. Crypto server. I can actually stand up this container. Oh, come on, jar. So I can actually stand up this container locally and spin up a Java thing talking to a Postgres, a real Postgres, and a real Memcached, and talk to it. So I happen to have some end-to-end tests here. Super simple. Just a couple of curls that talks to hostname. Pretend that's not pointing at staging, but localhost. If we run it. Oh, no. What did I do? HTTPS. Sorry, live demos are fun, right? I hope they're fun. Is anyone not having fun? Good, I'm holding you to that. So I just happened to, so this is something that you could then take to your QA team and say, look, I've got a Docker, I've got local data. Like, if you want to do end-to-end testing, black box testing on this service, if you wanted to write a shell script that curls and posts and awks and greps and whatever, it's not that hard. I don't have to worry about spinning up a separate Postgres server somewhere in an environment. I don't have to persist anything. We don't need a staging environment just to test one simple service. We just stand it up locally on our build server, for example. And when we're done, we can decommission the whole thing. And that's another cool thing about Docker is that you don't run the risk of polluting your build server. So if your developer says, I just want Python 3.3.3, you know, if your malicious developer puts apt-get install Python 3.3.3 and your build system is CentOS, somebody just hosed your build system, and now you have to go fix it. If you have a Docker container, you just stuff it in a container, spin it up, use it, and then throw it away when you're done with it. And that's awesome. I promise. Blah, blah, blah. Cool. And then if you have to deal with, I shouldn't say it that way, if you get to deal with, oh yeah, this is totally just, all right, we'll just pretend I didn't bother going back to the slides. If you had a developer, really smart developer, but let's say you're a Java shop, or she, you're right, sorry, let's say she comes up to you and says, you know, I know we're a Java shop, and I'm a JavaScript developer, and I really like JavaScript, so I don't want to learn Java, but I want to do this backend service. I've heard of this great thing called Node. Let's build a thing in Node. And so you can either, as an ops guy, go and install Node on certain specialized machines that are provisioned to do this whole thing, or you can stand up a Docker swarm and ask for a Docker file. And if this works, do I need network for this? All right, we'll pretend this works. Docker PS, Docker images. Did I already build the image? Oh, I totally did. Name and eyes. The Book of Rick. All right. Oh, gosh. Oh, wait, no. Because it's not even called that. It is called Focused Banash. I want to keep you on your toes. So if we run it and we expose a couple of ports, oh, you're killing me. All right, I was wrong. You were right. No, wait, hold on. I was right. Uh, 3,000. Oh, come on. Yo, and you fail. SalesforceIQ, the book of. This is secretly just a comedian. So if we take a look, I happen to expose a port. Oh, come on. Docker PS. Did I really not expose the port? No, it's right there. Docker machine IP dev. It is that. I'm secretly just delaying so that you guys can come up with really clever questions. It totally works, but the image doesn't load because I don't have network. So developer spun up this really cool tool that in like 30 seconds gives us a Facebook of all of our whole team. And that's a really powerful thing and not something that she would have ever written in Java. Because Java, I mean, are you kidding me? Like enterprise. Right? Like who wants to write a 10-line or 100-line node script in Java? It's like 1,000 lines. Right? It's totally ridiculous. Also, these are my coworkers, and they're all awesome. Well, except for that one guy. It worked! It worked! Hi, Gary. Yay, caching. OK, cool. So yay, caching. OK, so that's basically it. I mean, I just have a whole bunch of really cool Docker things that I wanted to show you guys. I've shown you a few of them. I have a bunch of slides that I'm not going to do because they're hard. But I am going to do this one. So I'll do one last slide. So one of the really cool things about Docker, and I'm going to be a little bit of a promotionist here because Docker. One of the really cool things about it is it's not some company shipping a product that we're all consuming. So there is Docker, and they are contributing to this code base, but there's also Mesosphere. They're building a Docker machine that you can run a whole bunch of stuff on. There's Kubernetes. There's Amazon ECS. There's Windows Azure. IBM is building a solution for Docker. Like, come on, everybody's doing Docker. Even Heroku, which I think they announced like last week. So like everybody is doing Docker because it's so easy to ship. Not only is it for your ops team, but if you want to outsource your operations and just run a thing somewhere, it's as simple as building a Docker container. And 90% of their contributions aren't from the company. Like most of this code is open source. Most of this code is written by people like you and me who hate this bug or hate that thing or hate this thing and just fixed it. And that's really cool. So I hope I answered questions, and I hope I have questions. When would I use Chef instead of Docker? Do I have to? So the one thing that it is a good question. So one of the things that we do at RelateIQ is our persistence layer is not Dockerized for the most part. So we run Mongo and Cassandra and Elasticsearch, and for those things, because they're semi-stateful, it's not that they're like things that can run anywhere. They're things that have to run on a specific machine. That problem is very quickly going away. We just haven't updated ourselves to get there. Mesos, for example, launched 3 months ago, 6 months ago, somewhere around there. They launched this like persistent files volume storage thing. So in theory and in practice, you could run a stateful disk-full service like Kafka on Mesos and dynamically spin up and spin down. So I think if I had to, I would run Chef for persistence, but I kind of don't want to do that either. There was a question up here at the top.
Yeah, I'm just trying to figure out how some of the moving parts come together.
Sure.
The container is specific to the underlying operating system, but the Docker file is abstract. You can take a Docker file and make it two different Dockers running on different underlying operating systems.
Yeah, so the question was basically what's a Docker container? I think we'll start with that. So a Docker file is like a makefile in it that it describes how a thing should be built. A Docker image is a thing that you can version and deploy that says, I want Node, I want Python, I want npm start to be the default command, I want these npm packages. And then the container itself is the thing that's running. So as soon as you start that guy, you take the deploy target and run him, then that's the actual container. So for example, so it's not specific to the underlying operating system. There are like some nuances with the way that Docker does isolation depends on the kernel. And that's the only association you have with the underlying system, is that
Could you take an image file that was created in one operating system and deploy it to a Docker container that was running on top of a different operating system?
you could take a Docker image that was built on one type of machine and deploy it on another type of machine. It gets a little bit tricky so you need the kernel to have isolation. So you need a mature enough Linux kernel. And you need, so Raspberry Pis come up with this because they have an AMD architecture instead of x86. You need to have built said container, said image on the same architecture. So if you build an x86 thing, you need to run it on an x86 thing that has kernel support. And then from that point on, it doesn't really, there's no you don't need to worry about Python in the underlying system or Go or any of that stuff. So it's it's like the packaging requires some assumptions on what's being built and shipped. And then the container itself, the thing that's actually running, the thing that's serving your requests and answering on port 80 or running a CLI command or what have you, he basically takes a photocopy of that image, slaps on one mutable file system on top of it so it can do local manipulation, and then runs in isolation. And so once you're isolated, it doesn't really matter which machine you're running on unless you happen to expect the host machine to give you a volume or your host machine to share its network with you. And so there's some breakdown of stuff there, but I hope that answers your.
It's a one-to-one, and in that image,
So yes, so each container has one image. Each machine can run as many containers as fits in memory. And you can have multiple images on the same machine. So for example, on my laptop, I'm actually running both Postgres and memcached on the same VM. One of them started with a Postgres image, one of them started with a memcached, and then I wrote to the Postgres table, so we saved some state there. And that's not shared with the image, that's shared with its own little box of the world. And so I can stop it and start it and still have that data there. But yeah, does that answer your? All right, awesome. Cool. Blue shirt.
What orchestration tool are you using? Are you using like Docker Swarm, Mesos, Kubernetes, the CoreOS version, or which one?
Yeah, so we are using Mesos and Mesosphere. We're also using our own homegrown Mesos and Mesosphere. And we're also using Mesos and Mesosphere version 0.7. And we're also using, we're using a few different things. We've gotten to play around with a whole bunch of stuff. I think we're going to be sticking with Mesosphere for the time being, because we really like, or I really like their UI. Which is a terrible answer. But since they're all going after the same process, I think they're all like pretty competitive, and it's mostly a stylistic choice, or if you're trying to shoehorn into existing infrastructure. For example, if you're running on a Salesforce pod, you might want to run on a rack deployment instead of a EC2 deployment. Over here? Yeah, so I can talk very briefly about some tooling that other people at my company have done. That's always fun, and I can totally take credit for them. So one of the things that we do regularly is we sync our data. So SalesforceIQ has a collection of data that we keep track of, both time series data with important relationships and an address book, essentially, contact management type stuff. And so one of the things that we've seen with Salesforce, with HubSpot, with Marketo, with Pardot is that our customers want to sync that data with some regularity. And that sounds like a pretty fun problem, and it sounds like it's totally not worth solving in Java. And so our developers actually spun up a whole team and wrote an integration in Python. It runs just every 5 minutes or so and copies data over. It does like a differential sync. You're sitting right next to one of the people working on it, so she's taking photos. I can't tell if you're turning red, but you should be. And so that's like the type of thing that we're hoping to take advantage of with Salesforce is if you want to run a thing and you don't really care where it runs, or if you want it to run on a Salesforce pod, then when you run on a Salesforce pod, or if you want to run an integration, a third-party integration that syncs with Salesforce, you might want to run those things in a sandbox somewhere that you own but doesn't have direct access, for example, to your database. So we spun up a data center totally separate, but we run a Python job that, in theory, anyone could write. We happen to write the first one, but one could imagine third-party developers submitting more containers. And those things can run in isolation. You feed it a few API keys, and it syncs things like address books, which we've gotten a lot of leverage out of. I don't know if that answers your question exactly, but great. Cool. So we have 1 minute and 45 for 3 seconds left. Any more questions? Excellent.
How is it running on stuff other than Ubuntu?
So how is it running on stuff other than Ubuntu? I don't actually know how it's running on Windows. The way that a lot of people are doing it is they're running CoreOS, which has the same kernel capabilities. Azure does its own thing, and Microsoft, so I'm sure it works, but I don't know that I want to know how it works. And then for like Mac development, what we do is we just spin up a Ubuntu VM and run it there. I saw one more question in the back. Yes. I am so glad you asked, because I was just looking at this thing the other day. I'm going to nerd out for a few minutes. The rest of you are welcome to leave. So the cool thing is, one thing is we deploy to our own Docker registry. So we have a list of all of the containers that we deploy. And you can very easily separate your production environment from Docker, the public registry. So you can control what's being deployed to your cloud just through network and VPN and stuff like that. Then once you have the containers deployed to a thing, you can actually do stuff with them. Their Docker registry has a really, really rich API, and there are already 2 companies out there, Banyan Ops. Oh, yeah, totally forgot to load that screen. So there are actually 2 companies that are specifically going after security, and the way that it works, in a nutshell, is they spin up the container, which is a full Linux thing, right? It's a full Linux process, and then download a bunch of analytics tools and run those tools on that container, and then you can either certify that container is clean from SSL vulnerabilities. Sorry, now I'm getting excited. Or reject it, right? So like the nice thing about having a thing that's deployed that's just Linux is you can do all sorts of like anything that you can awk, sed, grep, pipe, JQ, you can do with a Docker container. These guys are actually productionizing it. So you can ship your containers to them. So you push your image both to your private registry and to them, or you give them access to your private registry and they ETL everything over, and then run security, like best practice tools and CVE exploit scripts and stuff like that to find out whether it's legit or whether it needs to be fixed. Does that answer your question? Good. Well, all right. So I'm technically out of time, but I'll be around afterwards. I hope you enjoyed this as much as I did. No. CTO of the company doesn't mean you get engineering.salesforceiq.com. It's where we blog about all of our really cool stuff, and we're in the process of getting it back up. So if you guys went and checked it out and gave me lots of hits so that I could argue with our PMs that we should totally back it, that would be awesome. Oh, and we're hiring. Always hiring. God. Jobs at salesforceiq.com? Sure. OK. All right, get out of here.